quite happy with how we did on that test yesterday. Just telling Mr. Kubowitz that I was actually somewhat impressed with how all that went. So hopefully the same thing will happen here. There is a lot of stuff in this chapter, though. All right, so just be mindful of that. All right, so a little warm-up. Let's talk about some general vocab that we assume you know already, and then we'll kind of get into some new things here on the next page, assuming we have some time. So let's do a quick little review. So if I ask you what is the diameter of a circle, it says be specific by including what points of the circle it connects, and then draw a picture. So let's actually start by drawing a circle. Let me try my fancy new ink to shape here. All right, good. All right, so that's our circle. I want you to draw in what you think the diameter of the circle looks like. Like, where is it? What does it look like? All that good stuff that you probably know. And then when we do that, there's two things that have to happen in order for this to truly be the diameter of a circle. Because we really could draw in a bunch of different spots of this. All right. Anybody think they know what a diameter of a circle should do here? These two got it in here. This is a what?
Like a whole line and the whole circle goes through the diameter and it's like half of it.
Okay, I like that.
Where do you have your diameter going through what?
Good. So here's what Ahmed said. You probably can't hear him on the other side of the room. He says you must go through, we're going to give it a fancy name, through the middle of the circle. So that's what he said in his words, and I like that. So the middle of our circle, not that there's some fancy, super fancy math word for this, but when we start talking about the middle of the circle, we basically say that's the center of our circle. So we must pass through the center of our circle. So if you look at the one that you would have drawn in there, if you don't go through the center, that's not a diameter. All right, so this word is important. This word is critical. So you may have drawn one that, kind of does this, but if it doesn't go through the center, that's not a diameter. And then the other thing he said, it has to go through the whole circle. What you basically have to say is it connects 2 points on the circle. So here's 2 points connected on the circle. Like, we'll talk about what this is. There is a fancy math word for that. That's not the diameter, because not only do we need to connect 2 points on the circle, you must at the same time pass through the center of the circle. So hopefully we all have, and don't judge me here, I'm going to draw this way. It connects these 2 points, and we go right through the center of our circle. So that'll be our diameter. All right, then Ahmed kind of said this already. This I think we all now know. If I now draw in another circle, and I ask you for the radius, the first thing still has to be true. Let's put connect, because we don't really pass through at this time. We must connect the center. So find the center of your circle. I guess it's not really bullets, it's just one statement. We must connect the center of the circle to any point on the circle. So there's a whole bunch of radii possible here. So if I put my dot right here, connect it to the center, that's a radius. If I would have put my dot over here, connect it, that's a radius. We have all kinds of different places we could have drawn in our radius. Okay. I am recording it. I think I did. Did I not record this? Let me see. Yeah, we're good. Thank you. It's all right. I usually forget. All right, number 3. What is a straight angle? And then how many degrees does a straight angle have? Draw a picture. A straight angle is really fancy geometry word or phrase for basically a straight line. So a straight angle is basically a straight line. And then the second element of that, what degrees does a straight straight angle have? So the degree measure idea, you would have dealt with this last year when you were doing rotations and everything in Math 1. What you talked about a lot, actually you do 180 last year too, but you deal a lot with 90 degrees. A straight angle, you actually do this in Math 1 now that I think about this. A straight angle is a straight line with 180 degrees. Because if you just think, if I draw in a 90 degree angle here, wouldn't I also have to have a 90 degree angle here? If I draw in two perpendicular lines, if one side is 90, the other side is 90, that means this entire angle connecting a straight line, any points on a straight line, has to be 180 degrees, okay? All right, do we know supplementary? Do we remember this? I believe these are all things that you have seen before in 8th grade or last year. Sound familiar to anybody? Don't remember? Okay, then do this for me then, if we don't recall. Draw a straight line again. Instead of, like the first time, so don't draw what I'm going to draw in right now. Instead of me drawing a straight line down where these are both 90, even though we could, what I want you to do is draw a little line that extends out from a certain point. And then just recall what we just talked about at the top here in number 3. Don't we have a straight line? So if I call this angle 1 and angle 2, don't angle 1 and angle 2 have to add up overall to be 180 degrees because they make up a straight line? So supplementary angles are two angles. These are our example, our picture, two angles whose sum is 180 degrees. So really, even up here, these are supplementary angles too, right? 90 and 90 add up to be a 180. We would consider those 180. If I add some numbers in right here, so if you want to add some numbers, you could do that. Let's say I say this is 150 degrees. Then I would know for sure this would have to be 30 degrees because those added up need to equal 180. Okay. You also have something called complementary angles. So let's draw a picture of this. This time, go ahead and don't draw a straight line. Draw a 90-degree angle for me. See if we can do that. We've already drawn one. So drawing a 90-degree angle. Easy way to think of a 90-degree angle is when you're driving your car, most intersections are 90 degrees. It's a perfect T if you think of the letter T. So a complementary angle, I'm going to draw in like this, or a 90-degree angle is like this. So that's 90 degrees if it's a nice T. Supplementary angles add up to be 180. Complementary angles add up to be 90. So what I'm going to have you do is in that 90-degree angle, have a little point and just extend a line out from that point. If they are two angles, so let's write this in, two angles whose sum is 90 degrees, then if this overall is 90, let's say I tell you that this first angle is, let's say 20 degrees, then we would know if these all together make up a 90-degree angle, if they're complementary, then this would have to be 70 degrees. That's what complementary means. Those two angles have a sum of 90 degrees, okay? All right, 6 says, name the following angle in as many ways as possible. Be sure of the proper notation. So first, the way we define an angle, so if you ever see this little notation, that's an angle notation. So this little thing here, when we write this, means angle. Just like when I do 70 and I put the little circle at the top of this, that means the degrees. Whenever you see this little kind of, it's not an inequality sign. It's similar to an inequality sign. All right, that means angle. And the reason it's called that is because we're creating a little angle right in here between those two lines. So when I do this, there are 3 different ways that I can name this angle. One of the ways we can name it, we would call this angle. Think about the V's that we just did, all these absolute value graphs. Remember how we called this the vertex? Angles also have a vertex. Letter B, where the angle is formed, so here's angle number 1. Letter B is our vertex. When we name an angle, so we're going to put all 3 letters in here, the vertex must be the middle variable. The B has to go first. In fact, the second way we're going to do that is almost the same, and the B just has to go, did I say first? It has to go second. It has to go in that middle line. So one way we could name this, we could say it's the angle formed by point A to B to C. So we would just call it angle ABC. And then we know since B is in the middle, that's the vertex of that angle. The order in which we do those doesn't matter. So I could also say CBA. So we could also call this angle CBA. Those define the exact same angle. Then, and this is a big one, I actually could, because if I look at my vertex B, see how there is only one and only one angle here? Because of that, there's only one angle extending out from B. I actually could just call this angle B. That would be okay. Whoa, that's cool. I don't know where that came from, but yeah, I'm going to turn off my ink to shape, I think. I can't delete that. It won't let me get rid of it. All right, let's just, let me get rid of that. Can I cross it out? It won't even let me cross it out. All right, that is called angle B. There we go. It was weird. All right, now let's go up to this one real quick. Don't necessarily change yours, but let's make sure we understand when we can use just a single variable and when we can't. So if we look at the one that I have drawn up here in number 5, notice how I have a B. So if I ask you to name this angle, and again, you don't necessarily have to write this, just make a mental note of this. We'll do this plenty. I could call this angle ABC. I could call angle CBA, because B is the middle. What I cannot do in number 3, we can't now just call this angle B. The reason for that, angle B is there's 3 different vertices for angle B. Doesn't letter B, couldn't we draw an angle right here? And then isn't C a non-factor whatsoever? B could also be defined as this angle right here, right? Isn't that a vertex? Let me actually put a point out here that's D. So I could do angle ABD, DBC, and then don't we also have this 90-degree angle ABC? So there's 3 different angles, this little red one, the little purple one, and the big purple one. So since there's 3 different angles in B, we couldn't use this notation for this one. We have to be now specific with 3. Since there's only one angle formed here, we could, if we want, just call that angle B. Okay? So know that. And then, okay, good. This would be a nice one to stop with then. Name the following segments in 2 different ways, and then be sure to use proper notation. So, let me get here. The way we're going to name this are 2 different ways. Since we have segment YZ, you're going to write those 2. Y indicates one of the endpoints, Z is the other endpoint. Proper notation for this is a line segment on the top. Do not put arrows on the end of this. That means something different. It is a segment. We do not go left and right forever. Similar to up here where we talked about, as long as the B is in the middle, it doesn't matter the A and the C and the C and the A, the order doesn't matter. It's the same with this. We could call this segment ZY, and it defines the exact same thing because one's the starting point and then one is the ending point. Okay? You're going to get a lot of these little definitions and notations, and eventually you're going to deal with something like this. A ZY with arrows at the end is different than this. A ZY with one arrow and one dot means something different than these. So each one of these notations is very, very important. Now, we haven't talked about it yet, but that's what I'm saying. You want to really kind of be aware. There's a lot of little things to be aware of in this chapter when we dive into all this geometry stuff. And the proper notation is important with all of it. Okay. All right. No sense in going on. It's kind of a nice ending. So bring this on Monday, and then we'll dive headfirst now into the first section of Module 5. Okay. All right. If you did have any questions, you got a couple of minutes if you want to stick around to ask those questions on the quiz test. If not, see you second period. And if not, we'll see you on Monday. All right. Take it easy. Have a good weekend. It is an intervention. All right. See you, Kim.